Hi everyone. So today we're going to talk about measures of variation. So this is the first part of a two-part lecture about this topic. Okay, so let's begin. So for the goals of this video tutorial, you will learn how to calculate the measures of variation for the given data and also to interpret the measures of variation. So previously, we already discussed a measure of central tendency, and that is finding the central location of a given data. For measures of variation, we are more concerned on how spread out the data is, okay? And how the data values are related from the center, okay? So suppose we are given this histogram, and let's say this is the center of the data. Okay, so in measures of variation, we are more concerned on how each scores deviates from the mean or the distance of each scores from the center point. Okay, and then there are four measures of variation. So these are the range, interquartile range, variance, and standard deviation. For this video tutorial, we will discuss first with the range and interquartile range. Okay, so let's start with the range. So in finding the range, all you have to do is to identify the maximum data value and the minimum data value of your data set. So the formula in finding the range is maximum value minus the minimum value. So remember, when you are finding the range of a given data, you just need to consider the endpoints. Okay, these are the maximum value and the minimum value. Okay, so suppose you are given this data and these are the scores of the students in a math exam. So to find the range of the data set, we will start with identifying the maximum value. And the maximum value is 8. Okay, and then next will be the minimum value. And the minimum value is 2. Okay, so to find the range, we just subtract the maximum and the minimum value. So that is 8 minus 2. And 8 minus 2 is 6. So the range of the data set is 6. Okay, let's proceed with the second measure, which is the interquartile range. But before we proceed with some examples on how to find the interquartile range, we will recall the quartiles. Okay, remember, median divides the data into two parts. Okay, two equal parts. So let's say this is our median. Okay, so it divides your data set into two equal parts. The scores above the median, we call it the upper half. Okay, and the scores below the median, we call it the lower half. So in finding the quartiles, we're just going to follow the following definitions. First, the lower quartile is the middle value of the lower half. Okay, and then the upper quartile, it is the middle value of the upper half. Okay, so quartile 1 represents the lower quartile. So let's say this is the middle value of the upper half. So this becomes quartile 3. Okay, and let's say this is the middle value of the lower half, and that becomes quartile 1. Median is quartile 2. Okay. Okay, so we're going to use the same examples that we used a while ago. Okay, 1, 2, 3. Okay, so we're going to use the same data that we used a while ago. Okay, so to find the quartiles of the data set, the first thing that we need to identify is the median. Okay, so in finding the median, we need to arrange the data set in ascending order. So this is the ascending order of the data set. Since we have 13 values, okay, so to find the median of the data set, we're going to use the formula n plus 1 over 2. So that is 13 plus 1 over 2. So 14 divided by 2, that is 7. So our median is the 7th order on our data set. Okay, so the 7th order is 5. Okay, so our median is 5. Okay, so to find the upper quartile and the lower quartile, we need to identify first the upper half and the lower half. So this is the upper half, okay, and then this is the lower half. Okay, so to find quartile 1, we need to find the middle value of our lower half. The middle value of our lower half is 3 and 4. Okay, so to get the quartile 1, we need to average 3 and 4. So the average of 3 and 4 is 7 divided by 2, which is 3.5. So our quartile 1 is 3.5. Okay, so to find quartile 3, we need to get the middle value of the upper half. Okay, so the middle values of our upper half is 6 and 7. Okay, so to find quartile 3, we will get the average of 6 and 7. So 6 plus 7 divided by 2. So that is 13 over 2, which is 6.5. Okay, so that's it. So we have the median, which is 5. Okay, and the other symbol for the median is quartile 2. Okay, do not forget that. Okay, then quartile 1, that is the middle value of the lower half. So in our example, that is 3 and 4. So we will get the average of 3 and 4, which is 3.5. Okay, and for quartile 3, that is the middle value of the upper half, which is 6 and 7. So we will get the average of it. So that is 6.5. Okay, so that's how you find the quartiles of a given data set. Okay, so how is it related to our interquartile range? So let's have the definition of the interquartile range. So the interquartile range is the range of the middle half of the data. So the middle half of the data that we're talking about here is quartile 1 and quartile 3. Okay, that's what we call the middle half. Okay, so the formula in finding the interquartile range is Q3 minus Q1. Okay, so suppose we are given the same example. So to find the interquartile range, we will just identify the value of quartile 1 and quartile 3. But we already calculated quartile 1 and quartile 3 from our previous example. So quartile 1, that is 3.5, and quartile 3, that is 6.5. So to find the IQR, we will just subtract 6.5 and 3.5. So 6.5 minus 3.5 is 3. So that is our interquartile range. Okay? Okay, so let's proceed with this problem. So Jane and Ashley's monthly telephone bills are shown below. So we have the data for Jane's monthly telephone bill and Ashley's monthly telephone bills. So we're going to answer the following. Find the mean and median for each data set. Find the range and interquartile range for each set. And we will answer the following questions. Which person generally pays more for their telephone bills? Which person has the greater variability in their telephone bills? So to answer letter C, okay, just to give you an idea, to know which person generally pays more, we will consider later on the value of the mean. To answer which person has the greater variability, we will consider the value of the IQR or the interquartile range. Okay, so let's start with finding the mean and median followed by the range and interquartile range. So to find the mean and median for Jane and Ashley's data, it will be easier for us if the data is already in ascending order. Okay, so I already arranged the data in ascending order. So later on, when we calculate the median, it will be easier for us to locate the middle value. Okay, so let's start with Jane's data. Okay, so we will calculate the mean first. Okay, so to calculate the mean, we will add all the scores. Okay, and then divided by the number of entries. So when we add all the scores, the total is 428, and then there are 12 entries, so the mean is 428 divided by 12, and that is 35.67. Okay, so to find the median, we will use the formula n plus 1 over 2 to locate the middle value. So we have 12 data values rather. Okay, so that will be 12 plus 1 over 2, and that is 6.5. So it means our median is between the 6th and the 7th value. So our 6th and 7th value are 36 and 36. So to find the median, we will get the average of 36 and 36. So the median will be 36 plus 36 divided by 2. 36 plus 36 is 72. Divided by 2, that is 36. Okay? So our mean is 35.67. Our median is $36. Okay? Let's proceed with Ashley's data. Okay, so we will calculate the mean. So we will add all the scores. Okay, so the total of all the scores is 369 divided by the number of entries, which is 12. So 369 divided by 12 is 30.75. Okay, so to find the median, we will use n plus 1 over 2 to locate the middle value. So we have 12 entries plus 1 divided by 2, so that is 6.5. And 6.5 is between the 6th and the 7th value. Okay, so the 6th and the 7th value are both 26. Okay, so to find the median, we will just get the average of 26 and 26. So the median will be 26 plus 26 divided by 2. So that is 52 over 2. So you have 26. Okay, so the mean is 30.75 and the median is $26 for Ashley's data. Okay, so let's proceed with the second question. Okay, so we want to find the range and the interquartile range for each set. Okay, so to find the range for Jane's data, okay, we need to identify the minimum and the maximum value. The maximum value for Jane's data is 47 and the minimum value is 29. Okay, so the range will be the difference of the maximum and the minimum value. So that is 47 minus 29, which is 18. Okay, for the interquartile range, we need to identify the lower quartile and the upper quartile, which is Q1 and Q3. Okay, so we will start with Q1. Okay, since our median is 36, okay, so 36 is located here. So this will be our upper half. Okay, and this will be our lower half. Okay, so to find the first quartile um, or the quartile 1, okay, we need to get the middle value of our lower half. So the middle values are 29 and 31 for the lower half. So to get quartile 1, we need to average 29 and 31. So 29 plus 31 divided by 2, which is 60 over 2. So 60 over 2 is 30. Okay. For quartile 3, so this our upper half. So the middle values are 38 and 40. Okay. So to get the third quartile, we will get the average of 38 and 40. Okay, so 38 plus 40 divided by 2. Okay, so 38 plus 40 is 78 divided by 2. So that is 39. Okay, so our range is 18. Our quartile 1 is 30. Our quartile 3 is 39. So to compute the interquartile range, we will just get the difference of quartile 3 and quartile 1. So Q3 is 39 minus quartile 1, which is 30. So 39 minus 30 is 9. Okay, so our IQR is 9. Okay, let's have Ashley's data. Okay, so we will compute the range. So the maximum value in Ashley's data is 59 and the minimum value is 19. So to find the range, we will just subtract the maximum and the minimum. So 59 minus 19 equals to 40. Okay, and then we will calculate quartile 1 and quartile 3 before we calculate the interquartile range. So the median of Ashley's data is 26. Okay, so it is located here. So this will be our upper half. Then this will be our lower half. Okay, so to find the first quartile, we will get the middle of our lower half. So the middle values of our lower half are 23 and 24. Okay, so to get the first quartile, we will just get the average of the two middle values. So 23 plus 24 divided by 2. So 23 plus 24 is 47 divided by 2, so that is 23.5. Okay, and then for quartile 3, the two middle values in our upper half is 35 and 40. Okay, so we need to get the average of 35 and 40 to find our third quartile. Okay, so 35 plus 40 divided by 2, so that is 75 divided by 2, which is 37.5. Okay, so our range is 40, quartile 1 is 23.5, quartile 3 is 37.5. So we can now calculate our interquartile range. So we will just subtract quartile 3 and quartile 1. So 37.5 minus 23.5, and that is 14. Okay, so our interquartile range for Ashley's data is 14. Okay, so we already have our descriptive statistics, the value of the mean, the median, the range, and the interquartile range. So we can now answer the third and fourth question. So the third question, which person generally pays more for their telephone bill? So we need to consider the value of the mean here. Okay, we will compare the value of the mean for Jane and Ashley's data. Jane has a mean of $35.67 and Ashley has a mean of $30.75. Okay, since we're asking for the person which generally pays more, we will consider the person which has the higher mean, and that is Jane. Okay, so let's write our conclusion. Okay, so since Jane has the higher value of mean or has the higher mean, therefore she generally pays more. For their telephone bills. Okay, so let's have the fourth question. Okay, so which person has the greater variability in their telephone bill? So we will consider the value of the interquartile range. So in our previous calculations, Jane has an IQR of 9 and Ashley has an IQR of 14. So greater variability means higher value of IQR. Since Ashley has the higher value of IQR compared than Jane, then she has the greater variability. Okay, so let's write our conclusion. So since Ashley has the higher IQR, therefore she has she has the greater variability in their telephone bills. Okay, so remember when you are answering problems in statistics, not just in statistics, it is important to always state your conclusion in context. Okay, so just like what we did in our example. Okay, so that's it for today. I'll see you in our next tutorial video. Okay, goodbye.